Hello, in this video we'll be introducing implicit differentiation and looking at the process that's involved. So first questions first, what do we mean by an implicit equation? Well, an equation in the form y equals f of x, as we've met in the past, that is described as explicit, whereas an equation where x and y are jumbled up to some degree is described as implicit. So where it says notation in the textbook box, it gives examples such as x squared plus 2xy equals 3 or cos of x plus y equals 2x. Both of those are examples of implicit equations. And then over on the left, I'm not going to go through this, but essentially what it's talking about are sort of functions of y, for which we're going to use the chain rule, and then products of functions of x and y, for which we're going to use the product rule. So as it says at the top, we need to be able to differentiate with respect to x terms which are given as functions of y using the chain rule, and terms given as functions of y and x which will be times together using the product rule. So our first example, we have v equals y cubed, and if we want to differentiate that with respect to x, then we want to know what dv by dx would look like. So we can set up a chain rule. So dv by dx equals, now we can work out dv by dy, so that means we need to times it by dy by dx in order that the dy's cancel, and we're left with dv by dx. dv by dy is 3y squared. We can't do anything with dy by dx, so we're left with the fact that dv by dx is 3y squared dy by dx. And by exactly the same logic, if we have v equals ln y, then dv by dx will be dv by dy, which is 1 over y times by dy by dx. So dv by dx equals 1 over y dy by dx. And again, if v equals sec y, then dv by dy will be sec y tan y. So dv by dx is going to be sec y tan y dy by dx. And as I'm sure you'll have noticed by now, you get what basically you would have thought you might have got, but with y's, but you'll end up timesing it by dy by dx. So just to emphasize the fact, if we have v equals 2y to the 5, then dv by dx will be 10y to the 4 dy by dx. If v equals e to the 2y, then dv by dx is 2e to the 2y times dy by dx. And if v equals 5 over y, or 5y to the minus 1, then if we differentiate 5y to the minus 1 with respect to y, we get minus 5y to the minus 2. So dv by dx can be written as minus 5 over y squared times dy by dx. So going back up to the top, we do need to be able to differentiate with respect to x terms given as functions of y and x, which are multiplied together using the product rule. Here's our first example, uv equals xy squared, and we want to know what u dv by dx plus v du by dx would equal. So to start off with, we can split it into two bits like our product. So u equals x and v equals y squared. So du by dx equals 1, as it always has been. But dv by dx, we are differentiating v equals y squared, but with respect to x. So we need to use the method we've just been doing for the last few minutes. So dv by dx is 2y dy by dx. And then we finish off with the product rule. So uv dash is 2xy dy by dx. vu dash is y squared. Add them together. So the differential of xy squared with respect to x is 2xy dy by dx plus y squared. Notice we're not putting equal to dy by dx, we're not doing that. In this example, we want to differentiate e to the x plus y, and we should know that e to the x plus y is the same as e to the x times e to the y, because when we're multiplying terms with the same base, we add the indices together. So we can write that u equals e to the x and v equals e to the y. Differentiating e to the x with respect to x gives us e to the x, of course. Differentiating e to the y with respect to x will give us e to the y dy by dx. And then that will give us uv dash, which is e to the x times e to the y dy by dx, which we could write as e to the x plus y dy by dx, and vu dash as e to the y times e to the x, which we can also write as e to the x plus y. And if you really want to, you can then factorize e to the x plus y, so that you get e to the x plus y multiplied by 1 plus dy by dx. Finally, we might want to differentiate cosec x cot y. So if we let u equal cosec x and v equal cot y and differentiate them both, the differential of cosec x with respect to x is minus cosec x cot x. The differential of cot y with respect to x is minus cosec squared y dy by dx. And then the product rule gives us minus cosec x cosec squared y dy by x minus cosec x cot y. So let's just talk through 3 further examples of the product rule. So if we have xy cubed, we can let u equals x and v equal y cubed. Du by dx will equal 1, but dv by dx will equal 3y squared dy by dx. So when we use the product rule, we're going to times x by 3y squared dy by dx and y cubed by 1, and that will give us y cubed plus 3xy squared dy by dx. Again, notice it's not equal to anything. For sine x cos y, the differential of sine x with respect to x is cos x. The differential of cos y with respect to x is minus sine y dy by dx. And again, by combining them, sine x times minus sine y dy by dx is minus sine x sine y dy by dx. And cos y times cos x is cos x cos y. So that's why we get the answer written there. And then for tan x tan y, if u equals tan x, then du by dx equals sec squared x. Whereas if v equals tan y, then dv by dx equals sec squared y dy by dx. And then cross multiplication again for the product rule gives us the answer there. Thank you very much.